So yes, my name's Max Smythe. I'm a platform engineer here at SendHub. I'm glad you all could make it, and I'm excited to be talking to you guys about OpsWorks and Fabric, systems automation and continuous integration. So, when we think about a website and hosting a website, just even a simple website model has quite a lot to it. You got your load balancer, you've got some web servers, probably a database. If you have any asynchronous events, you're going to need a queue and some workers to service, the tasks in that queue. So there's a lot going on. And this comes with a number of issues because there are a number of disparate hosts. You have different packages that you need to have installed. And really the main issue is scalability. So although in my slide I have 3 web servers and 3 workers for a very large website, with infinite scalability, the intent is to be able to let that number 3 go to however many servers are needed to handle that traffic. And if you're trying to do all of this manually, that model quickly breaks down. If you have just a simple maintenance task, takes 2 minutes to perform, and you have 200 servers that you're trying to maintain, if you're doing that by hand, it's going to take you 6 hours just to do that one simple task. So there's a lot of room just to improve things here. And the main source of improving that model is going to be through automation. And if you come with the idea of continuous integration, automation is further necessary because with continuous integration, you're going to be deploying many times a day. And if there's anything other than minor manual interaction that has to go on with that, then continuous integration is going to very quickly become a burden. So it's an important question to answer. And part of answering that question then is, if we're going to automate systems, what kinds of things do we want to automate? And just looking at the graph, as I said, there's different hosts, different packages that we probably need for each host. So a good place to start would probably be just automatically installing packages. That's cool. We could do, say, a bash shell script and it'd do that quite handily. And of course, we're going to automate deploying code, and there are many services available for that, build servers for whatever language of your choice. So there's solutions that are available for that. But just automating installation doesn't really complete the picture for a network, because in a network, everything needs to be aware of everything else on the network in some form. For instance, if I spin up a new web server, and all I do is launch that server, it's not going to be doing very much until the load balancer has that web server added to its round robin. It's just going to be sitting there with no traffic. So we also need to automate the interconnections between hosts. And that's where that's where things start to get tricky. And that's where things like shell script really hit their limitation. Also, because of the variety, you'll wind up with limitations in terms of, as you add more different types of hosts to the queue or to your infrastructure, things just start getting very top heavy and weighted down. So OpsWorks is Amazon's attempt at solving this problem of automation. And it's free, so it's a great solution to start trying out. So when OpsWorks looks at this system, it doesn't look at things just on the machine level. That's not how it breaks the problem down. What it sees is something that looks more like this. So in OpsWorks' mind, how a web app is organized at the highest level is with something called a stack. And a stack is just that, a full web stack. And for OpsWorks, the actual stack object would hold things like the global configuration parameters for your project. And it would be kind of the access point through which you would do things like maintaining your infrastructure, updating packages, that kind of thing. And at the next level down, you would get something called a layer. And a layer is just a set of one or more homogeneous instances with a single purpose. So with that idea, what Amazon stores in a layer are just the blueprints for hosts. So not only the things we were talking about where you're installing packages and those specific ways of configuring the hosts, but also how hosts react to changes in the infrastructure, like adding or removing other hosts in the system. And then at the very most granular level, you do still have something called the AWS instance, and it is the same instance we've all come to know and love. But before I really get down into the nitty-gritty of how you do this kind of coordination, I did want to talk a little bit about how that blueprint works, how OpsWorks does the automation of installing packages. And to do that, I have to talk about Chef. And Chef is an automation framework in its own right. It's developed by OpsCode, which the company has actually changed its name to Chef. And Chef uses something called recipes to describe what a host should be doing. And they're written in Ruby using their own special domain-specific language. You could think of a recipe as kind of a script declaring what you want to do with the system. So this is just a sample recipe that I have. And the purpose of this recipe is to configure log forwarding on a web host to a log aggregation server. And if you'll notice the structure, it's kind of organized into 3 different stanzas. Each of those stanzas is using what in the Chef world they call a resource. And this first stanza uses the service resource, and the full only purpose of that right now is to let Chef know that there is a system service called our syslog, and it supports actions like restarting, stopping, starting, reload, that kind of thing. And where the meat of the configuration actually happens is in the middle, this middle stanza here, this template resource. What the template resource does is you can take an embedded Ruby template, and you can use information about the state of the system and information you've supplied about how you want it to be configured to fill out that template and create a file, in this case at C, our syslog.conf, to get the machine in a state that you want. And you'll notice that at the very bottom, there's this notifies keyword that's referring to this our syslog service. So what's happening there is after the template gets written out, our syslog is informed that it's time now to restart. And then the bottom stanza is just it's a sanity check. It's making sure by using pgrep and shelling out that there's a service called our syslog and it's indeed running. If it's not, then please do start it. So there's been a little bit of hand waving in terms of stack attributes attributes and configuration and state of the system. And to get more specific about that, OpsWorks uses what's called stack attributes. And there are 2 sources, really, where you could draw stack attributes from. There's the sort of static stack attributes that you can add in at the web interface level. There's something called the custom JSON attribute, and it's really just a standard JSON object, and you can put whatever attributes you want in it in whatever format you'd like, provided it's JSON, and access it just dynamically inside of your Chef recipes or inside of your templates. The other way attributes can be sort of injected into the stack is dynamically by OpsWorks itself. So when OpsWorks is running some sort of event, what it will do is it will record what machines belong to which layer and the vital information about the machines, such as the AMI ID, the IP address, that kind of thing, and just make it available to you in case you need it. So here's a good example. So following with that Chef recipe that I was showing you, the one that was configuring our syslog, if you remember, I had this template resource that relied on an embedded Ruby template. And this is just a snippet from that template to give you an idea. The top line is just proof that it's for our syslog, because the rest of it looks a lot like code to me. And in this middle line, this middle stanza, what I'm trying to do here is just grab a list of applications, CentHub specific code applications that are associated with the current instance that this recipe is being run on, or this template is being compiled on. So in this third line down, you can see they have node OpsWorks instance layers.each. That's an example of accessing those attributes. So whenever something's prefixed with OpsWorks, that's going to mean the dynamic attributes. That's the stuff that OpsWorks is providing for you about the state of the system. In this case, instance is talking about this specific instance, and layers is the instance attribute that tells me what layers this instance belongs to. So I'm just iterating over those, and in the middle of my loop, what I have is this node CentHub layers layer app name, and that's my pre-coded attributes that I've added. So I have in my JSON, my custom JSON, I have CentHub, and I have under CentHub layers, and I have each of the layer names. And for this particular layer, which hopefully exists, I will have an attribute called app name, which will tell me what application that layer is designed to serve. And so once I've kind of gathered that information, in the last stanza, I could bring it all together. And in that middle line there, that's our syslog TCP forwarding. And I just pull out the IP address of the log server I want to forward to, and then the specific port that I'm forwarding logs to for that specific application type. And really, you can see how this adds flexibility. I'm no longer tied to hard coding in IP addresses into my server, or sorry, into my chef recipe. I can put them in the custom JSON, and should they ever change, I don't need to recompile anything or redeploy recipes. I just need to update it in that one spot. And I can also do things like add apps, extra apps, really easily, and just check on the state of the stack generally. Now that's all well and good. We're able to conceive of the problem, and we're able to tell things what to do, but we don't yet have a mechanism to actually trigger that action. And that's where events come into play. So events, if you remember, I was talking about how the layer really describes the blueprint of what instances, its member instances are supposed to look like and how they're supposed to react to certain things. So in this slide, what I have is a screenshot of OpsWorks, particularly the layer configuration. And this is just for the custom layer. There are a few default recipes that get run at certain times. And each of those bold words are different events. So there's setup, configure, deploy, undeploy, shutdown. I don't want to talk about all of them. I will talk about just a couple of them. And on the right of those little blue boxed words, those are different chef recipes that are prescribed to run when those particular events happen. So provided you want to model something that is captured by this event structure, you can make your stack responsive. All right, so the first event I'd like to talk about is the setup event. Setup is run after an instance is launched. It's automatically run, and it's a great place for putting things like default packages you like to be installed and for configuring an instance to run in the way you'd like it to run before making it available generally. And a more interesting event, at least in my mind, is the configure event. So after setup is run, what happens is on every instance in the stack, the configure event is invoked on every single instance. So what that means is that you now have an opportunity to, on your load balancer, when you launch a web server, you can check, are there any more machines that I need to add into my load balancer config, and update your config accordingly. And this you can extrapolate into really any level of complexity, integrating any number of machines with any other number of machines. So now we do have really great framework for systems management. I haven't really talked about deployment yet for good reason, but we will get to that. Before I move on, I wanted to talk about some of the things that OpsWorks gives us for free, which I love. So one of the things that OpsWorks does for us is Amazon does, through CloudWatch, give us monitoring of hosts, which is good. I'm glad we have it. But OpsWorks takes it to the next level by using this knowledge it has about our web application, because we've been forced to kind of inform Amazon how we're sorting things, that these hosts belongs to this stack and in particular this layer. So maybe there's some more useful ways we could look at the data. So if I go into monitoring, for instance, at the stack level, what I can see is machine usage data averaged over all members of the layer. So it's a good sort of overview about how much resources I'm using on which machines. Am I sizing my machines correctly for the type of work that I'm doing on them? But say I have an issue and I want to, look a little closer, debug things. I actually get, this is the coolest one, the ability to look at the different hosts in a given layer side by side and look at their behavior and see how they relate to other hosts in the same layer. So it's very likely if some machine is behaving abnormally that I'm going to see different usage patterns in maybe the CPU, maybe the loads. If it's a memory leak, the memory. I've seen things where the memory caps off and then troughs because we've hit some sort of limit and the process died. So it's very useful information. And we can still dig further deeper and get all of the available CloudWatch monitoring, just generally. If that's not enough for you, they do have Ganglia just hard-coded into the OpsWorks infrastructure. So it would be very easy just to launch a Ganglia instance and start aggregating data that way and getting some more detailed historical views. Another couple cool features that OpsWorks gives me are auto-healing and auto-scaling. So when OpsWorks notices that a host is not behaving properly, it's maybe not responding, it's possible, if I've enabled it to invoke auto-healing. And what that will do is it will kill the current host, launch a new host with exactly the same configuration, and swap any EBS volumes if there are any. And so effectively, it's hot swapping my machines for me. And this can oftentimes, because I believe it's a 5-minute pull time, it will happen fast enough that it will fix a problem before you've even noticed and have gotten time to, boot up your machine to fix it yourself. The other useful feature is auto-scaling, and this can be done at the layer level. So you know how usage is not always constant over time. People go to sleep at night, for instance, so they're less likely to be using your website. And auto-scaling gives you the opportunity to take advantage of those usage patterns, to not pay for AWS instance machine time when you don't need it. And there are two sort of approaches you could take to that. You can either do time-based scaling and, say, boot up a bunch of machines at 6 a.m. and kill them at 8 p.m. or whatever makes sense for your schedule. Or you could do a little bit more flexible load-based scaling, where you can take some thresholds, say if load on my machine exceeds a certain level, CPU usage, RAM usage. If it exceeds this threshold, launch more machines. As it goes under that threshold, kill them. And that can save some prediction time. Now, although Fabric is a really awesome infrastructure, it's free, it does what we'd like it to do very well, just the concept in general does have a few limitations. One of them being if you want to model an event that doesn't really fit into that event framework, I've not personally needed to, it becomes very hard to do. You can sort of invoke custom recipes at will, but I've had limited results, limited success for that. Sometimes they do hang. It's much more reliable just to rely on the default events. Another limitation is just that invoking recipes can be a little slow, not outlandishly. It's like 1 to 3 minutes, so it's really nitpicky. But if you have something like bringing a site into or out of maintenance mode and you don't want to spend that amount of downtime, you can speed things up a little bit by SSHing into the host directly. The last sort of limitation is you get control over the order with which chef recipes are executed, but you don't necessarily get control over the order of which in which they're executed on different hosts. So if you need to do something like round-robin updating, it's a little difficult. You could do some sort of weird workarounds, like having 2 layers that do exactly the same thing, update one layer, then the other. But you're really fighting the paradigm at that point. So for something like continuous integration, where deployment has, if you do it in the wrong order, a very real potential of bringing down your web page, you want that control, which really brings me to Fabric. So Fabric is a Python wrapper around SSH at its simplest. It has a huge amount of utility functions. For instance, it's very easy to run something serially. It's very easy to run it in parallel along a lot of hosts. It's just a matter of changing a decorator. And you can run shell commands locally. You can run them remotely. Lots of context management, a really rich library, but with a very basic concept, so you have a lot of granular control over what happens. So this is an example of a Fabric recipe, or sorry, a Fabric, just a fab file is what they call it, and specifically a Fabric task. And I just wanted to point out a few of the cool things here. If you look at the top, there's a decorator called @parallel. That's all you need to run a Fabric task on several hosts in parallel, in this case, chunked 10 hosts at a time. So you could, in theory, do sort of like a grouped round robin in this way. And I also want to point out just how easy it is to shell out. It's just run make dir -p and then your directory name, and you've now made a directory on every single host that Fabric is run on. And it does accumulate return codes. It is possible to aggregate that data, so if you want some kind of results summary, you're fully capable of doing that, which is great for checking to see just how successful your deployment was. So because you get all of this fine-grained control, you can do things like change the way your deployment workflow goes. You can optimize things to be maximally safe, and that's really great. Now, Fabric and OpsWorks, although they're both systems automations frameworks, I find they really do work very well together. Each one sort of complements the other one's shortcomings. So Fabric, like I've been saying, you get a lot of fine-grained control, but it has no awareness of what hosts exist where on your system. It has no way of maintaining that information either. So you're either going to need to build your own, or you could use OpsWorks. You can use OpsWorks API to give Fabric the information it needs. Well, as OpsWorks, you don't have as much control, but it's much more robust. You're not developing your own kind of workflow. Chef recipes are very well tested, so you can really leverage the community and help you build things out faster. It's also, OpsWorks is a bit more scalable, I imagine, than Fabric, because with Fabric, you have one master host, and that doesn't necessarily scale well to hundreds, thousands of machines. All right, so although there is a little bit of synergy where one sort of covers the other's weaknesses, there are a few rough edges with trying to use Fabric and OpsWorks together. So with auto-scaling in particular, if you're deploying and you have some sort of Fabric script and you're pushing your code out and auto-scaling launches an instance mid-deploy, if you haven't sort of thought things through, it's very possible to wind up with a race condition where the newly created machine will be deployed with the old code, and everything else will have the new code. And you're like, I thought I fixed that bug, but it's still appearing one time out of 20, or however many instances I have. What is happening? And it, could be you didn't take into account something like that. And another sort of breaking area is on the other side of the auto-scaling. If you kill an instance mid-deploy and it's part of Fabric's host list, that SSH connection, Fabric caches their SSH connections. It's not going to be valid. It's possible that there will be a timeout, and the default behavior for Fabric in that case is to crash. So you're going to need to really think carefully about both timeout times and how to handle errors like down host. And so I just, in building out a Fabric deployment script, because it's so free, I did want to give just a few tips that I've sort of encountered building our own here at CentHub. And the first and biggest tip I can find is do as much work as possible before you actually flip the switch and roll out your new code. Because there's a lot that needs to be done, and there's a lot that can fail. And if it fails before you've moved things over, then your site is still in a consistent state, and you could debug the failure at your own pace. Whereas if it's in a half-complete, half-deployed state, then you're going to run into issues, and you're going to be much more stressed. The other thing I would say is fail loudly. If a deploy fails, you want to let as many people know about it as quickly as possible. So if the engineer who started the deploy is off debugging a different issue or something like that, someone can easily make him or her aware. All right, and also make it really easy to revert a bad deploy. Not all code is perfect. Sometimes there are bugs. And the less time it takes to change things back, the less time you're annoying your users. So what this generally boils down to is do keep older versions on the host. Don't spend time re-downloading the host to host if you can avoid it. Also, you may want to consider, if you're using Python, for instance, versioning the virtual environment if you're using venv. So if you install a new version of a pip package that you've been using and it winds up breaking your system, to try to revert that change, if you're just simply snowballing it all together and you keep updating the same venv with new pip packages, it's going to be very hard. You're going to need to rebuild your entire virtual environment in order to roll back that change. Instead, if you keep your virtual environments versioned and you keep them on the machine, not only will you not need to rebuild, you won't need to re-download, and oftentimes reverting is just a matter of flipping a soft link and restarting the service. Let's see, any other fun tips? Oh yes, the last one, and do take this one with a grain of salt, is because certain things can be very bandwidth intensive. Like, for instance, a Python virtual environment with a lot of packages can be on the order of gigabytes. Sometimes you can get a huge performance boost by soft linking or hard linking when it's available to you. There is a very large caveat with this, however, particularly with virtual environments, and that is that oftentimes things are hard-coded, and so linking to a different, if you're ordering things with commit hashes, linking to a different virtual environment very easily can break things. Some examples of this for Python are in the virtual environment bin activate script. It hard codes the actual path of the virtual environment, and if you're using links to point to the most current one, you want to be sure to update that script. There's also a soft link in the packages directory that points to a fully qualified path, and if you don't update that one, it will continue pointing to the old version, and Python will continually import from the older version until you clean it up at some point in time. And if you do that mid-Python run, suddenly imports will start to fail. And because you just randomly are cleaning stuff up, it won't happen consistently, and it'll be very hard to debug. So do weigh the benefits. You need to keep a sharp eye out if you're linking, but there are significant benefits. And finally, I just wanted to take the opportunity to thank a few people. Steve Garrity of Hearsay Labs, in particular. When we set out building this new deployment system, he was instrumental in helping us, and in a lot of ways. He helped us sort of get our grasp around Chef, and talked about the various ideas that they employed for their deployment system, and sort of giving us some scratch to work off of to help us build our own. Amazon, I would like to thank for building this product and making it free. It's been instrumental in improving our performance on our website. And thank you to opscode/chef for building Chef, because that's what all this is based on. The Fabric development team, and of course, SendHub for employing me, hosting this, being awesome generally. Thank you. So, yes?
If you already have Chef set up and you already have Chef in your home environment for all your machines, are there advantages to migrating to OpsWorks?
I would say not necessarily. It depends on what you're trying to get out of it. Because Chef there's a lot more flexibility with Chef, and a lot more control over what happens. Where OpsWorks really excels in what it gives you for free. So it comes with a web management console where you get all of the monitoring and all of that stuff. You don't need to build out events or anything like that.
Just following up to that, you started with OpsWorks, right?
Started with OpsWorks as opposed to...
You didn't have a previous Chef deployment? Did you just start with OpsWorks?
As far as using Chef, no. OpsWorks is our first venture that used Chef.
Make sure we repeat the questions.
Oh, thank you. Yeah, so the first two questions were, is there any advantages in moving from Chef to OpsWorks? And I would say maybe monitoring, maybe self-healing, that kind of thing. And the second question was, did we start out with some sort of Chef implementation? And the answer was no.
So there's a deploy event that OpsWorks gives us. If you're using Fabric, does that correlate at all when you do code deploys? Or we're still using Fabric to deploy the code at certain other events where OpsWorks is not handling that, right? Or,
yeah, the deploy event is an interesting one. To repeat the question. The question was, there's a deploy event and...
in OpsWorks, does it correlate to the Fabric's deploy?
Does it correlate to the Fabric deploy in any way, shape, or form? Yes and no. So the deploy event is an interesting one in that it's actually invoked manually through the OpsWorks interface if you choose to go with one of their prepackaged solutions, which they don't have one for Python. They have some for Ruby and Java, I believe. But it also gets invoked automatically as the last step in the setup process. So what we use it for is we do actually use it as a way to, when you launch a new host, to signal to our build server, hey, we need code in this new host. And how that works is because Fabric is invocable from the command line, it's very easy to sort of integrate it with Chef just using the execute resource. And so when we launch a host, as our deploy recipe, it submits a request just in the form of a file saying this host needs to be provisioned with code. And then as part of the configure event, what will happen is our deployment server, which is a member of this whole OpsWorks stack, checks for any of these sort of requests and satisfies them then.
So that we can use auto-healing and auto-scaling and Fabric's deployment as sort of...
Oh, yeah. So if we auto-heal, our code will be deployed. Yeah.
also keep it in OpsWorks and have multiple hosts as your devs did, or
Oh,
that's the question.
okay, so the question was, how does this whole setup relate to our dev environment? And that's one of the things I'm most proud of, is that our development environments are 100% separate, and it's very easy to keep them that way. So OpsWorks lets you copy a stack and paste it. So we could take our prod stack, we could copy it, we could create a new stack, and use it to test whatever we want, including changes to our deployment system and to our chef recipes.
What do developers do locally to imitate the system, or does it all, are they developing in the cloud basically?
So the question is, what do developers do locally to imitate the system? Chances are, I mean, we develop on Macintoshes, and there's kind of a split depending on the level of testing you really need to do before you bring it to something that's even closer to live. It's a lot of us, I in particular, I just run the services on the shell locally in the Macintosh, and they're all connected to localhost. We do have also a Vagrant image that we use, but in terms of the multi-machine complex virtual environment, that all lives in the cloud.
Is there a way to sync, like if auto scaling spun up like 10 new boxes, does your Fabric script hit some API to know about that, or do you have to then bring those new box IPs into your Fabric script so that it knows about these 10 new boxes that are in production?
So we actually haven't needed to use autoscaling directly for our website. One thing, though, one of the considerations I have is, as the very first step in a deploy, what's marked as the current, before even the hosts that we're going to deploy to are gathered, what's marked as our current version is switched over to the newer version. So if we invoke the process of, you know, this new host gets spun up and requests code, it's going to request the most recent version of the code. And if for some reason the host gets spun up, you know.
I guess, or is it keeping in sync with all the boxes in production? Like, is there some API that your Fabric script can hit to say, give me all the boxes in this layer?
Oh, no.
Or do you have to manually configure it?
Well, because there's that setup event that automatically provisions code, you just need to make sure that you're always pointing to the correct version by the time the setup event is invoked. And if not, that that eventually that host will be part of your deploy host list, and so it will get updated that way.
So the Fabric script does actually create an API from OpsWorks to know what machines to deploy to.
Yes, yes. So just to keep things simple, I shelled out with the AWS command line interface. You could use Boto too. There's an interface with OpsWorks there. An interesting bit of trivia is the OpsWorks interface is only in US East. So if the East is bombed, you won't be able to, you know, control your hosts that way, but your infrastructure will still be okay. It's just that automated behavior will break. Thank you.